Wufi, Wufi passive or Wufi plus. What does that mean? Such a funny name. But it's a German abbreviation. I don't want to get into, for what it stands, but it is a tool, I call it the second generation simulation tool that allows us to do a lot. It was developed by Fraunhofer Institute for Building Physics, which is one of the leading institutes, research institutes in Germany, and the Passive House Institute US, FIUS. And just to let you know, guys, as you know, there is a adoption of the Passive House standard to North America, and let me tell you, it is not watered down. It is just the fact that here in North America we have a lot of climates as opposed to continental Europe, where Passive House, the original Passive House standard, was developed. And there the climate is not as diverse as it is here in North America. So it is just an adjustment to the climates we have. We have many different type of climates. And again, it is not watered down. I can attest. Now, this is part of the SB12 building code. Greg and I were able to include Wufi passive in the building code. This is the first time that the name Passive House is mentioned in any building code in North America. I was actually sitting with the FIUS guys just 2 weeks ago in Philly for the Passive House conference, and they were pretty ecstatic. They looked at me and said, "How did you guys do it? We are trying to do this in Illinois for the past 10 years, and it's not possible." But again, for some reason, we had a decent person on the other side, and we were able to make the case. So basically, Wufi passive, we opened a new market for Wufi passive. It is now able, beside high-performance houses, we can now use it also to prove compliance with the building code when a building needs energy simulation, and that's when it has more than 22% wall-to-window area ratio. But again, in my opinion, any building that should have an energy simulation to see what we're doing, since we're trying to manage energy, and if we cannot measure something, we cannot manage it. So now there might be some confusion between Wufi Plus and Wufi Passive. It's virtually the same software. It's just that Wufi Passive tells you, how far you are from Passive House standard or whether you have achieved it or not. But other than that, it's essentially the same software. It's a dynamic, and I will come back to that to explain what dynamic here means, dynamic whole building simulation model. And the important part of that is it allows us to simulate the indoor climate. And again, there was this question about overheating. The indoor climate has a lot of other factors playing a role with, rather than just heat gain. And I'm going to get to that. But again, if we are able to simulate it, I think to me that's a huge leap, because most of the complaints that architects and builders face is discomfort. It's getting too hot here. It's too cold. So if we are able to simulate that, we can address it And I think that's a very good way of addressing problems that might come up in 2 years or even in 10 years, because we can also do a hygrothermal analysis, which is about seeing whether there will be any moisture accumulation within a wall. Again, we are building thick walls, and sometimes we're building walls that have hygroscopic materials like cellulose in it. And sometimes we want to know what's going to happen based on the climate we have built the house in. So now, the other good part of that is that we can import drawings, so we can spend less time on calculating surface areas, and now we can spend more time on analysis and, really the stuff that an energy simulation software allows us to do. So with the energy balance, that's the heat loss, heat gain calculation, annual heat loss, heat loss calculation. That's a simple calculation again. However, there we can also model the thermal bridges and analyze them more, because those thermal bridges are really the stuff that takes away from that high performance wall. And most of the time we don't have any sense what the effect is. And knowing the effect of a thermal bridge allows us to even optimize it, further optimize it. Now, simulating indoor climate. What are the factors? And again, it's a dynamic calculation. A dynamic calculation means that you take into account dynamic loads, which are, say, solar heat gain. It's an hour-by-hour calculation, as opposed to other software that do a monthly average of monthly climate data and calculate with that. So this is, it will allow us to say where in the house, at what time overheating may occur. And I think that's a great way of looking at the house, because, again, we're trying to eliminate complaints. Now, it does also a dynamic shading calculation. That means that what is the effect of this shading device on the other window when the sun is, in the afternoon? So usually the software we use cannot do that, because they just use monthly average weather data, whereas here we're looking at hour-by-hour calculations. And also it takes the thermal mass capacity of materials into account. For example, Graham has a visible concrete floor. You still have it, right? I do. Mm-hmm. So that floor, or even say a massive wall like Sylvia's house, inside the house can store the solar heat gain, prevent overheating, and release that heat over many hours later. So we can now simulate that in a software and see whether it is effective or we need more storage, so that we skip overheating or air conditioning. And also it simulates the relative humidity and CO2 content based on the specific use of the room or the zone we're looking at. So if we have a lot of plants, or there is a specific activity going on, or if it's a classroom, a room like this that suddenly it gets tons of load of humidity and makes it kind of uncomfortable, we can simulate that and see how we can counteract that with the mechanical or even passive measures like thermal storage. It includes also an airflow model because all these factors affect comfort. It depends. We don't like something blowing in our face. It might be warm. The ambient temperature might be warm, but if the cooling vent is blowing behind our head where we are sitting, that affects the comfort of it. So we can take that also into account. And also simulating the mechanical system and the response to the overheating or the issues might come up hour by hour in the house. So we can tune in the mechanical system, or see what other elegant ways there are to counteract the issue of comfort there. Also, you get also a video output of all dynamic simulations. In our climate, and again, now I want to talk about the hygrothermal calculation and talk about durability and risk. And again, I mentioned that we want to build high-performance houses. High-performance houses have thick walls. And also we want to use materials that are benign, recycled. Cellulose is one of those. In terms of, we can't do everything right, but again, we are looking into the moisture migration into a wall if something goes wrong. And based on the specific climate of that area where the house is, we can then see whether we're running a risk or not. And again, this simulation calculates the moisture accumulation over 10 years or 15 years, so we can assess whether, down the road, the little bit of moisture that accumulates into the wall over the years, whether it can pose any problems down the road. Again, for example, a double stud wall has a very cold surface, outer surface, and that might be a risk or might not be a risk. We don't know. Up until now, we really handled these issues as a, according to OBC, and regardless where we're building, there was just one formula of, that allowed us to see whether we're going to risk of moisture accumulation or not. Now, also on the other hand, we have a dynamic changing climate outside, and that really applies to Toronto. We have a cold winter, super cold winter, and hot, humid summer. So we got it all here. And basically, the software uses weather data that has the solar radiation in there, the driving rain factor is factored in, and also relative humidity and all the other good stuff. The software takes internal or external moisture sources into account. For example, raining. If an assembly gets a lot of rain and there is driving rain, we can do a stress test and see whether it can hold up or not. For example, again, I talked about the sheeting of a double stud wall. Is that going to pose a problem? What if we go for OSB or plywood or something else or zip sheeting? What are the implications? We don't know. Or that foam board on the exterior. Does that allow us to have an assembly that can dry out when something goes wrong? We don't know. However, we have all of this broad approach. Now, this summarizes really what Wufi passive or Wufi plus does. On this side, you see, the loads, the solar radiation, the temperature, of course, and precipitation. This is new. None of the other software were able to factor that in. So we can do a whole house dynamic simulation based on internal loads that we have, the window, the HVAC systems. But also we can go drill down into the assembly level and analyze the roof. We know that the side that's exposed to the sun, there will be relatively not much risk of anything going wrong there. But what about the other side? We know maybe that the south-facing wall may dry out. But what about the wall that's not getting heated by the sun? So we can do a hygrothermal analysis to see whether we're running the risk of anything that might occur or not. We can also do a thermal bridging calculation that allows us to further optimize the envelope, stuff that really we never were able to look at it the way now we can do. Thank you.